Good day, everyone. I am Jeremy F. Bautista,
And I am Lucifer Blanca,
and
and
we
we
are
are from
from
BSED
BSED
Science
Science 2.
2.
So, for today, we will discuss all about alcohol. But before we will begin our discussion, here are some objectives that the students are expected to attain at the end of this lesson. First is the students are expected to know what is alcohol in its general formula, understand the significance of alcohol as well as its various properties, name alcohols with both common names and EUPAC names. Lastly, to draw and identify its structural representation. So, if the structure is expressed in expanded structural formula, condensed structural formula, skeletal structural formula, or line angle formula. Do you know what is alcohol? What is alcohol? So historically, alcohol has been used in association with social activities, including both religious and non religious rituals, as a dietary component and as a medical or medicinal agent. Alcohol consumption by various cultures predates written history. Although it was once used for therapeutic purposes, it is no longer recommended as a therapeutic because of its ability to produce intoxication. The ability of ingested alcohol to get from the gut into the bloodstream and up to the brain where it produces the intoxicating effects is due to its chemical structure and solubility in water. So back then, alcohol is very or is widely used in social activities like religious and non-religious activities or rituals. So it is used as a dietary component and medicinal agent. But as the time goes by, the alcohol is no longer recommended as a therapeutic because it is intoxicating or it produces intoxication which is very toxic to our body, and the reason of its intoxication effects or intoxicating effects is due to its chemical structure and solubility in water. So that is alcohol back then. So now, let's proceed to the chemical structure of alcohol. So, let me give you to Miss Lisa Federica Blanca to explain this.
Okay, chemical structure of alcohol.
Okay.
Alcohols are organic molecules assembled from carbon, oxygen, and hydrogen atoms. When two carbons are present, the alcohol is called ethanol, also known as ethyl alcohol. Ethanol is the form of alcohol contained in beverages including beer, wine, and liquor. So as we can see, the picture below, that is a chemical structure of alcohol, which C stands for carbon, O stands for oxygen, and H stands for hydrogen. It is stated there that beer, wine, and liquor is also contained alcohol, which is ethanol. And now let's proceed to the importance of alcohol and its properties. Alcohols are among the most common organic compounds. They are used as sweeteners and in making perfumes, are valuable intermediates in the synthesis of other compounds, and are among the most abundantly produced organic chemicals in industry. Perhaps the two best known alcohols are ethanol and methanol or methyl alcohol. Ethanol is used in toiletries, pharmaceuticals, and fuels, and it's used to sterilize hospitals instruments. It is, moreover, the alcohol in alcoholic beverages. The anesthetic ether is also made from ethanol. Methanol is used as a solvent, as a raw material for the manufacture of formaldehyde and special resins, in special fuels, in antifreeze, and for cleaning metals. Alcohols have a big purpose and used in our generation. Ethanol is used for cleaning hospital instruments, and also it is present in any beverages. Methanol is used for solvent and also cleaning metals. And now let's proceed to commercially important alcohols. First is methanol. Methanol or methyl alcohol was originally produced by heating wood chips in the absence of air. Some of the carbohydrates in the wood are broken down to form methanol, and the methanol vapor is then condensed. This process led to the name wood alcohol as another common name for methanol. Methanol is synthesized commercially by a catalytic reaction of carbon monoxide with hydrogen gas under high temperature and pressure. So this picture is an example of methanol.
Next is we have the isopropyl alcohol. So isopropyl alcohol or 2-propanol is made by indirect hydration of propylene or CH2 or CH sub 2 CH sub 3. Isopropyl alcohol is commonly used as an industrial solvent and as a rubbing alcohol applied to the skin. Although isopropyl alcohol is more toxic than ethanol, it has less of a drying effect on the skin, and it is not regulated and taxed by the US government as is ethanol. So, when we say isopropyl alcohol, it is we are so familiar with this because this is the alcohol that we use if um, to kill bacteria on our hands, things like that. And then it is widely used in industrial solvent or as an industrial solvent and as a rubbing alcohol that is applied to the skin. So from the picture below, as you can see, this is the chemical reaction of the isopropyl alcohol. So we have here the propylene we mentioned a while ago, OSO3H, and the 2-propanol or the isopropyl alcohol. So next, so this is what we mean if we say isopropyl alcohol. So this product is by Green Cross. It has 70% solution. It is for antiseptic and disinfectant. It's also hypoallergenic with moisturizer. So that this is this isopropyl alcohol.
So next is ethylene glycol. The name ethylene glycol refers literally to the glycol made from ethylene. Its systematic name is ethane 1 and 2-diol. Ethylene glycol is commonly used as automotive antifreeze and as an ingredient in hydraulic fluids, printing inks, and paint solvent. It is also used as a reagent in making polyesters, explosives, alkyd resins, and synthetic waxes. So, ethylene glycol is used for antifreezing automotive. When we say automotive, it is related to or concerned with motor vehicles. We found this alcohol also in inks like printing inks, and also we used it for painting solvent. The picture below is the chemical reaction of ethylene glycol, which have ethylene, ethylene oxide, and ethylene glycol or ethane 1 and 2-diol. So
The
this picture is an example of ethylene
um,
glycol.
Next is glycerol. Glycerol, also called as glycerine, is a sweet syrupy substance with three alcohol hydroxyl groups. Its systematic name is propane 1, 2, 3 triol. Glycerol was first obtained as a byproduct of soap manufacture through the saponification or hydrolysis in base of fats. About 25 kilograms, that is equivalent to 60 pounds of glycerol, is obtained with each ton of soap. It can also be obtained by fermentation from molasses and sugar. During World War II, large quantities of glycerol were needed for the production of glyceryl trinitrate or nitroglycerine. This need was met by synthetic glycerol made from propylene, or CH2 yields to CH minus CH3. So basically, glycerol is sweet syrupy substance. So it has a three alcohol hydroxyl groups and was first obtained as a byproduct of soap manufacture through saponification. And then, as you can see below, this is the chemical reaction for glycerol. So as you can see, this is glycerol. This is what we mean when we say glycerol. Next is we have the properties of alcohols. So the properties of alcohols has two. So first, um, its physical properties and chemical properties. But let's go first into the physical properties of alcohols. So the physical properties of alcohol can be explained by the following points. So alcohols are colorless, so it has no color. They generally give a sweet smell except for glycerol and a few lower alcohols. So most of the alcohols has a sweet smell except for glycerol and others that has a lower alcohols. Next is they are flammable and produce a blue flame. So um, they are flammable, so they can be easily be ignited or be burned. And then they don't produce any smoke while burning. So unlike other substance, alcohol doesn't produce smoke when it is burning. Next is they are generally liquid at room temperature, although glycerol is a viscous liquid. So at liquid temperature or liquid temperature, room temperature, so the alcohols are liquid. Next is let's proceed into its chemical properties. First property or chemical property of alcohol is combustion of alcohol. So on heating ethanol gives carbon dioxide and water and burns with a blue flame. So this is the reaction given below. So C2H5OH plus 3O2 yields to 2CO2 plus 3H2O. So when you heat ethanol, it gives carbon dioxide and water, and when it burns, the color of the fire is or the flame is blue. Next property or chemical property is dehydration of alcohol. Alcohol can be dehydrated in an acidic medium. The removal of water molecules from a compound is called dehydration. Upon dehydration of alcohol, alkenes are produced. So, the process upon removing water molecules from a specific compound or a certain compound is called dehydration. And when you dehydrate the alcohol or alcohol, it produces alkenes. So, this is the reaction of the dehydration of alcohol. So, C2H5OH um, size H2CO4 yields to C2H4 plus H2O. Next is the reaction of alcohol with metal. So due to its acidic nature, alcohol reacts with metal and forms alcohol oxide. For example, when ethanol reacts with sodium, forms sodium etho- ethoxide and hydrogen gas. So the reaction is given below. So this is the reaction of when alcohol is exposed with metal. So let's remember that alcohol is very acidic. It is acidic in nature, and it is very reactive to metals. Next is the formation of halides from alcohols. Alcohol reacts with CHCl and forms alkyl halides by removal of hydroxyl group. So this is the reaction below. Next is we have the esterification. So esterification, alcohol reacts with a carboxylic acid in presence of a catalyst and forms ester. It is called Fischer esterification. So remember, it is called Fischer esterification, and this is the reaction below. Reaction for esterification of alcohol.
So we have here an application
So
of
let's now
alcohol. There is a long history of alcohol for myriad uses. For instance, monoalcohols are the most important alcohols that are used in industries. Some of the applications of alcohol are as follows. First is we use methanol for formaldehyde and fuel additive production. So for second, for alcoholic beverages, fuel additives solvent production is ethanol is mainly used. 1-propanol, 1-butanol, and isobutyl alcohol are used as a solvent and precursors to solvents. C6 to C11 alcohols are used for plasticizers in polyvinyl chloride and many more. Lastly, fatty alcohol or C12 to C18 are utilized as precursors to detergents.
proceed to the EUPAC nomenclature for alcohols. Alcohols with 1 to 4 carbon atoms are frequently called by common names, in which the name of alkyl group is followed by the word alcohol. So as you can see, these are the types of alcohol or different names of alcohol. We have the methyl alcohol, in which it is expressed to its condensed structural formula, ethyl alcohol, propyl alcohol, isopropyl alcohol. So this structure are all condensed structural formula. Next one,
So, in identifying AUPAC names and how to draw a structure, we have to follow three rules. So, first rule is the longest continuous chain of carbon atoms containing the OH group is taken as the parent compound, an alkane with the same number of carbon atoms. The chain is numbered from the end nearest the OH group. So later we will be having an example to clarify about these rules for more understanding and easy to apply.
the number that indicates the position of the OH group is prefixed to the name of the parent hydrocarbon, and the E ending of the parent alkane is replaced by the suffix OL. So the E ending of the parent alkane is replaced by the suffix OL. So in cyclic alcohols, the carbon atom bearing the OH group is designated C1. So that is the carbon 1. But the 1 is not used in the name. Substituents are named and numbered as in alkanes. So the number that indicates the position of the OH group is prefix. So it is named after its parent hydrocarbon. So and the E ending of the parent alkane is replaced by the suffix OL. And the carbon atom having the OH group is designated as carbon 1. But when naming it, 1 is not used. So instead, substituents are named and numbered as in alkanes. Next
Last
rule.
rule, if more than one OH group appears in the same molecule or polyhydroxy alcohols, suffixes such as diol and triol are used. In these cases, the E ending of the parent alkane is retained. So, unsa maning diol and triol? So, kabantay mo ng OH. So, when we say diol, duha ka OH group. When we say triol, tulo ka OH group ang nagamit. So, in last rule, we have to identify how many OH group are in there.
Since we are done with the rules of on how to name alcohol in its IUPAC names, let's proceed to the types of nomenclature in alcohols. So there are three systems of naming alcohols. First is the common or trivial system. Second is the carbonyl system, and IUPAC system. So as we can see here, we can see methane, ethane, propane, 2-methylpropane. So this is what we call the parent hydrocarbon. First, let's look into the methane. So the common name for methane is methyl alcohol, while its carbonyl name is carbinol. Its IUPAC name is methanol, and this is the formula of the parent hydrocarbon called methane. So as we can see here, the methyl is bonded by the hydroxyl group or the OH. Next is we have the ethane. So the ethane, the common name for ethane is ethyl alcohol. Its carbonyl name is methyl carbinol, and its IUPAC name is ethanol. So this is the formula of the ethane. So CH3 bonded by CH2 and bonded by the hydroxyl group. Next is let's proceed to the the different structural formula of an alcohol. So the first is we have the expanded structural formula of an alcohol. When we say expanded structural formula, this is a type of formula that shows all the atoms in a molecule and all bonds connecting the atoms. So this is more systematic, unlike the other structural formula. Since you will write all the carbon atoms, the hydrogen atoms, the oxygen, and the hydrogen, and so on. Next,
So next is a condensed structural formula of an alcohol. So when we say condensed structural formula, is a structural formula that uses groupings of atoms in which central atoms and the atoms connected to them are written as a group.
the last one is we have the line angle formula of an alcohol. So this structural formula, as you can see, there is a line, and only the OH can be seen. So the line here represents the carbon to carbon bond, and a carbon atom is understood to be present in at every point where lines meet and at the ends of lines. So in here, this is where the lines meet, or the vertices. This is assuming that there is a carbon here and there is a carbon here. Next one is to test your understanding about our discussion. Let's have an example. So first, let's give the IUPAC name for each compound. We have two examples. So how are we gonna solve this? So from the given, we have 10 carbon atoms in the longest continuous chain, or LCC, and then the LCC makes the compound a derivative of a Dakin rule. So Dakin rule, since it has 10 carbon atoms, and in mathematics, the decagon has 10 sides, right? And then the OH, where can we find the OH? So the OH is attached on, or is located at the third carbon. So in here, which makes it, since the OH, or the parent compound, is located in the third carbon, it makes the atom a 3 decanol. So it is 3 decanol, since the parent compound is attached on the third carbon, and it is decanol because again it has 10 carbon atoms. Okay, so the carbon atoms are numbered from the end closest to the OH group. So remember in rule number 1, we're in the group nearest to the OH, the hydroxyl group, it is where we start to count as C1. So in here from the given, the group closest to the OH, the parent carbon, is in the right side. So with that, we need to count um right to left. So C1, C2, and C3. So because CH3, CH2 is the group nearest or closest to OH. And that fixes the two methyl groups at the 6th and 8th positions. So as we can see here, we can notice that CH3 or the methyl is located at the 6th carbon atom, and then the other methyl is located at the um, 8th position of the carbon atom, and a total of two methyl groups. So with that, the name is 6 8 dimethyl 3 dicanol. So it is 8 dimethyl because the last methyl group is located at the 8 carbon atom, and it is dimethyl, so di means two, because in the given we have two methyl, right? And then we have 3 decanol because at the third position the parent compound is located at the third carbon. So it should not be 3 5 dimethyl 8 decanol. It should be 6 8 dimethyl 3 decanol. So the other example, so this is the next example. So HO, CH2, 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 OH. So we have here 1, 2, 3, 4, 5. So we have five carbon atoms in the longest continuous chain. Make the compound a derivative of pentane. So pentane, so in mathematics, pentagon has five sides, and in here we have five carbons. So it is pentane, right? 1, 2, 3, 4, 5. And remember, we started to count here because um because the carbon, the central atom, which is carbon, is bonded by the hydroxyl group. But in here, the oxygen, only the oxygen is bonded. So because of that, we need to start to count here because the oxygen is bonded by the carbon. So with that, from the rule number 1, the group nearest to the hydroxyl group, which is the HO or OH, should be counted. Um, should be counted, or it is where we start to count. So we have carbon 1, 2, 3, 4, and 5. So two OH groups on the first and fifth carbon atoms make the compound a diol and give the name 1,5-pentane diol. So remember that diol contains a hydroxyl group. So in here we have two hydroxyl group. So we find the first hydroxyl group at the first attached the first carbon, and the second hydroxyl group is attached to the fifth carbon atoms. So in here, so because of that, it makes the compound a diol because this compound is has two hydroxyl groups, and it should be named as 1, 1, 5, 5, since it has five carbons. Pentane diol. So pentane because it has five carbons, and in mathematics the pentagon has five sides, so it is 5-pentane diol. So another example to deepen your understanding.
So another example number two. Draw the structure for each compound. Number 1, 2-hexanol. Number 2, 3-methyl and 2-pentanol. So the class is we need to put first a 6 carbon which is hex stands for 6. So finally we add enough hydrogen atoms to give each carbon atom 4 bonds. So gipang-ada ra nato ang carbon ug hydrogen then giband nato ang carbon sa OH.
So that's all for today, guys. I hope you learned something from our discussion about alcohol and how to give its EUPAC names. And I just hope that you will not forget your learnings about this topic because this is very significant, especially when you take a board exam. Again, this is Sarame F. Bautista, and
And again, I am Lucifer Blanca,
your
your teacher
teachers
for
for today.
today.
That's all, guys. Thank you.
Thank you
Be
and
safe.
goodbye. And also have a nice day.